So in these problems, what we're going to do is we're going to simplify those square roots first, and then once we simplify them, we're going to see if we have any like terms that we can combine. So for that first one, the square root of 200 plus the square root of 50, what's the first thing we need to do for that problem? So first thing we want to do is factor that 200. What's that going to look like when we factor it? Somebody help me out. 20 times 10. And then the 20 is 10 times 2. 2 is prime. 10 keeps going. 2 times 5. And the other 10 is also 2 times 5, right? Now, we're going to factor the 200 and rewrite it, but we're also going to need to rewrite the 50, right? So let's go ahead and factor that one while we're at it. How does 50 factor? 5 and 10. And the 10 is 2 and 5. All right, so now we're going to rewrite it. Since we're rewriting this expression, what are we going to put before we put anything else? We're going to put an equal sign. The equal sign is just showing that what I'm going to write here is equal to or has the same value of what I started with. All right, so my first square root, the square root of 200, is going to turn into the square root of 'All right, and then we've got a plus sign, and then another square root for the square root of 50, which is
2 times 5 times 5.
all right, now what? We want to simplify each of those square roots, so we're going to circle pairs, right? So any pair that we have inside of one of those square roots is going to go outside of the square root. So for the first one, we have a pair of 2's and a pair of 5's. And the second one, we have a pair of 5's, right? So those circled pairs now are going to go outside the square root. So we're going to rewrite it again. And so for the first square root here, what are we going to have on the outside, Jack?
You're going to have a 2 and times 5.
Okay, so we'll have 2 times 5, which is 10.
Yeah.
Yep. And then what do we have left on the inside?
2.
Okay. And then we got a plus sign between, and then what do we have on the outside for the second square root?
5.
And what's on the inside?
2.
All right. So at this point, we've simplified the square roots. That's the first step. That's the hardest step. Now that we've simplified them, what can we do? Yeah, so these two have the same radicand. They have the same square root. So they're like terms, which means that we can add the coefficients together. So Dartavian, what's 10 plus 5?
15.
All right, and then what do we do with the square root part? We keep it the same. Okay, just like if we were adding 10x plus 5x, we would end up with 15x, or if we were adding 10 bananas plus 5 bananas, we'd have 15 bananas. Okay, the things that we're adding stay the same. So we're adding square root of 2's, we end up with square root of 2's. We don't change that. So our final answer is 15 square root of 2. Before we go on to the next one, I want to just mention a couple of things. Don't forget your equal signs between your steps. So what we'll do is we'll just put it at the beginning of each line. Those equal signs show that what we have on that line is equal to the line before it. Also, when you're doing your work, what a lot of people will do is they'll make a factor tree and put a square root here, and they'll make a factor tree and put a square root here, but they're not really in the same line. When we go from step to step, we want to bring the whole line down. So we have the square root of 200 plus the square root of 50, and then we rewrite that whole line on the next step. Okay, don't just put things in random places on your paper, but be sure you keep it organized. This problem here is the same thing, except we have 4 square roots that we have to simplify. So let's start with factor trees, just like we did the last one. How does square root of 45, how does that 45 factor? 5 times 9. 5's prime, 9 is composite. 3 times 3. Okay, how about the 18? I heard a couple of different things. 9 and 2 is one of them. 9 is 3 times 3. Okay, how about 80? 10 is 8. Okay, and then how about the 2 here? We can't factor that, right? So we're going to keep that the same. Even though we're going to keep it the same, we need to make sure that we include that every step along the way. So don't forget that in one step, because then you might forget it in the next one, you might forget it in your answer, so we want to be careful about that. All right, so the next thing we do is rewrite it. In that first square root, instead of 45, what are we going to have? Okay, in the second square root, instead of 18, what are we going to have? In the next square root, and notice that we're subtracting the next one, so we've got a minus here. What are we going to have instead of 80? Okay, I'll make sure my square root's big enough to cover all that. And then my next square root, we're adding, that one's going to stay the same, right? It's just the 2 in there. All right, now we're looking for pairs. Anybody see any pairs?
3.
So in that first one, we got a pair of 3s. In the second one, also a pair of 3s. In the third one, 2s, and another pair of 2s. And then any in the last one? Nope. All right, so time for another rewrite. So we're going to put equal sign, and then for the first square root, what's going to be on the outside? And on the inside? Okay, so we got 3 square root of 5 plus, what goes on the outside for the second one? 3 square root of, okay. Then we've got a minus 4, so we got 2 times 2 on the outside is 4, square root of 5. And then for the last one, we've got same thing. That doesn't change, right? Now, we do have some like terms here, right? What are our like terms? Square root of 2's we have right here and right here. And square root of 5's we have right here and right here. When we write our answer, which one of those do we want to put first? We want the least one, right? So we want the square root of 2's first. So let's go ahead and combine those. The square root of 2's, we have 3 square root of 2 plus square root of 2. If there's no coefficient, what can I put in front of this? 1, right? So it's 3 square root of 2 plus 1 square root of 2 gives us, what's 3 plus 1? 4 square root of 2, okay? And then for the square root of 5's, we have 3 square root of 5 minus 4 square root of 5. So forget about the square root of 5's. What's 3 minus 4? Negative 1. So we have minus 1 square root of 5. Is the order okay there? Do we do the order right? So we've got square roots from smallest to biggest. Okay, does anybody see a way we can maybe write this a little bit simpler? This is an okay answer here, but there's one thing that we can, well, get rid of. What don't we need there? That 1, right? So this would be an okay answer like this, or you could write the answer 4 square root of 2 minus square root of 5. You don't need that 1 in front of the square root of 5 because it doesn't really do anything.